I welcome you students to this third lecture on this exact differential equations. This is the third lecture we are going to share with you on exact differential equations. I hope you have got the lecture number 1 and lecture number 2 where we defined the exact differential equations and we deduced there the necessary and sufficient condition for an equation of the form m dx plus n dy is equal to 0 to be exact. Then we had some applications where we can apply this exact. How can we apply? The method of solution I have given. Now there are certain cases where differential equation fails to be exact. That is where you get partial of m, dou m by where you have dou m by dou y is not equal to dou n by dou x. We say the differential equation is not exact. In certain cases we can reduce the differential equation to the exact form. If we want to reduce the differential equation to the exact form, how can we go? For that we have the different method. We have actually integrating factor. This is now equations. These are equations reducible to exact form. We will be dealing with this. When it is possible to reduce the differential equation to exact form. In other words, each and every differential equation cannot be reduced to the exact form. We are dealing with the here first order exact differential equations. We have other methods then if it is not reducible. In certain cases, actually in competitive exams, in your entrance exams like PG entrances, even PhD entrances, and in competitive exams where you are given a differential equation, some differential equation is given and you have to find out it is integrating factor. Integrating factor is that factor which makes it exact, and out of 4 options you have to choose the correct one. What will be it is integrating factor. Then the examiner does not want to solve it, he wants only what is exact integrating factor. So you must learn integrating factor. So we write when m dx plus n dy is equal to 0 is not exact, we can make it exact in certain conditions. In some conditions it can be formed, it can be reduced to exact form. It is by integrating factor, which is integrating factor for this. You have also already done the integrating factor for py plus dy is equal to q. You write here integrating factor is e raised power integral of p dx. Actually that is a factor multiplied. You don't have their fully knowledge of that. What is e raised power integral of p dx? What actually that represents? Where from that comes? What is that extra? When you go higher and higher, you will learn that what is the utility and where from we get this integrating factor for dy by dx plus py is equal to q. There we only code the solution, the method. Here also it is a sort of method. In different forms for different differential equations we can find out the integrating factor. First I will define this. What is integrating factor? Integrating factor I will define. Integrating factor for exactness It is for exactness, to transform the equation into exact form when it is not. A function, it is a function, say function psi of xy. A function in x and y is said to be an integrating factor when we multiply the given equation by this factor makes the equation exact. Then what is? Then psi of xy is called integrating factor for given differential equation. It is the definition of, we have given you a definition. A function, say psi of xy, is said to be an integrating factor when we multiply the given function by the factor, by this factor makes the equation exact. Then psi of xy is called the integrating factor. Let us have the different rules. I will quote you some rules for when the differential equation m dx plus n dy is not of this form, it fails, it gives not equal to, then how can we make this equal? So let me have, we have different rules for this that we want to share with you. Well, rule number 1, I will say, a rule first, it is also known as homogeneous rule. It is called homogeneous rule. What is this homogeneous rule? Very simple. I will write it. It is if m dx plus n dy first order differential equation is not exact, is not exact. You have seen what is the condition for not exact? Partial of m with respect to y is not equal to partial of n with respect to x. If it is not exact, but equation number 1 is homogeneous in x and y, at the same time it is a homogeneous. You are very much familiar with homogeneous differential equations. You did it after variable separable method. When you introduce the differential equation, what is the differential equation, what is the order of the differential equation, what is the degree of the differential equation, how we solve the differential equation by variable separable method, then we go to homogeneous method, then we go to other methods like LD method, linear differential method, so on and so forth. There you know what is a homogeneous. I don't need to discuss here homogeneous. If it is a homogeneous, then 1 upon mx plus ny, 1 upon mx plus ny is integrating factor for equation number 1, but provided, condition is provided mx plus ny is not 0. It should not be 0. Now if it is 0, we can say this integrating factor fails. We don't get the integrating factor. But in case mx plus ny is 0, it is very simple to solve the given differential equation, because we can get there m in terms of n, use it here, then it is transformed to variable separable method. Don't say that it is not solvable when mx plus ny is 0. It is solvable very easily. You can solve it, but we don't need their integrating factor. In this way is not defined. We cannot find out integrating factor if mx plus ny is 0. So the condition is, it is a rider here that this should not be 0. Let me have an application on this. This is the rule number 1. Then I will give you rule number 2, rule number 3, 4 rules or 5 rules are there. Let me have an application so that you will understand how we apply these in problem solving, or we are given a question in the objective form, differential equation is given, we are asked there what is it is integrating factor. We have to when we find out integrating factor for the exactness, we have to identify the differential equation. If it is a homogeneous form, then we can say integrating factor can be 1 by mx plus ny. Yes, let me have an application on this. I will take an application on this. Let us have an application here. I will write solve the differential equation. Suppose it is 3xy square minus y cube dx plus xy square minus 2 x square y into dy is equal to 0. This is my differential equation. 3xy square minus y cube dx plus this. This is the differential equation. You see, if I first see it on basis of exactness, this is your m, this is your n. What is partial of m with respect to y? If you find it, it is 6xy minus 3y square. You know what is m? This is your m, this is your n. What is partial of n with respect to x? This will be y square minus 4xy. So it is different. When you differentiate this with respect to y, it is this, and they are not equal. So we say del m by del y is not equal to del n by del x. So not exact. Okay, this is not exact. It is not exact. So how should we go when it is not exact? But at the same time, you observe that it is a homogeneous function. What is how homogeneous? Degree here 2 plus 1 3, degree 3, 2 plus 1 3 degree, 2 plus 1 3 degree. It is a homogeneous, we say, of order third. It is a homogeneous, so it is integrating factor is so we see here equation number 1 is homogeneous. So we can have integrating factor is 1 by mx plus ny. Let me find out here what is mx plus ny. This is your m is this. It is 3xy square minus y cube into x, then plus n is that xy square minus 2x square y into y. Let us simplify this. This is your 3x square y square minus xy cube. This is plus xy cube. This is minus 2 x square y square. Now this gives you x square y square. So your what integrating factor will be, this is your mx plus ny equal to this, so it is 1 by x square y square is the integrating factor of this differential equation. When it was not exact, but it was a homogeneous of degree 3, so we could apply this formula, and you have seen that it is not 0 x square y square. Well, we will now multiply equation number 1 by this integrating factor. So let us multiply equation number 1 by 1 by x square y square. We multiply this by 1 by x square y square. You see where we reach. Well, when you multiply this, this will be given differential equation 3xy square minus y cube by x square y square dx plus xy square minus 2 x square y by x square y square into dy is equal to 0. Okay, let us see on simplification what does this gives you. It is 3 3 by x, it is 3 by x minus y square goes y by x square dx. This will be 1 by x minus 2 by y dy is equal to 0. This is now your transformed equation. This we call as transformed, reduced equation by multiplying factor. Now I will name this factor here m dash, because I have already denoted m by this and n by this. To avoid your confusion, you may not be in confusion. If you denote again this by m, you may use that. No, this is our transformed differential equation. I will write our m dash is here 3 by x minus y by x square. When I find out partial derivative, partial of dou of m dash by y, what is that? It is 0. It is your minus 1 by x square. I've had my n is here 1 by x minus 2 by y. What n dash? What is partial of n dash with respect to x? You see, derivative of 1 by x is minus 1 by x square, and this is 0. You see that they are equal. This partial of m dash with respect to y is partial of n dash with respect to x. They are equal. Hence, equation number 2 is exact. So what we have seen here, so this implies by this integrating factor, equation 2 is exact. What is its solution? Integral of m dash with respect to x plus integral of n dash with respect to y is equal to c. Here we treat as usual y constant, and here we take terms which are free from x, which do not involve x. From n dash we will take those terms which do not involve x. We have to write m dash full form. In full form, what is our m dash? It is 3 by x minus y by x square dx plus, what is n dash? It is your n dash but terms free from x. This involves x, leave it, minus 2 by y dy is equal to c. This we are doing by our previous method, how we solve the exact differential equation. Well, this on simplification gives me 3 times integral of 1 by x dx minus y is treated as constant, integral of x raised to power minus 2 dx, then minus 2 integral of 1 by y dy is equal to c. What is integral of this? It is log x. What is this? Minus 1 by minus 1. It is plus y by x. When you integrate minus x raised to power minus 2 plus 1 by minus 1. Then minus 2 log y is equal to c. You can say that it is the solution of given differential equation. When it was not exact but was homogeneous, we could transform it as exact form. Actually, I have already told you, you may, but if you apply the homogeneous method to this differential equation, which you did previously by putting y is equal to vx dy by dx, when it is homogeneous, we have homogeneous method y is equal to vx. There you will it will consume more time. But here you have seen it has not consumed much time. Therefore, those differential equations which are homogeneous can be sometimes and are not exact. We can tackle them, we can crack them by this method. Okay, let us have now second rule. You can do such questions in this way. We have now rule number 2. Rules 2. It states if m dx plus n dy is equal to 0 is not exact. Equation first is not exact, but it is of the form, लेकिन इसका form ये बनता है y into some function, say psi 1 of xy dx plus x times into some other function, say psi2, but involves xy into dy is equal to 0. You see how the function is. We can take, with dx, we can take y out. Interior function under bracket is a function involving xy. Here we have x out, and this function, this function I is psi2. It is a function in xy. This is also some function in xy. Xy out, some function in xy. Y out, some function in xy. If it is such, but not exact, then here integrating factor. Then integrating factor for this differential equation to reduce it into the exact form is 1 by mx minus ny. Here also provided mx minus ny is not 0. This denominator should not be 0. Even if it is 0, we can solve it by making x in terms of y using m in this equation. You can solve it. It does not mean when it is 0, it is 0, we can solve it. Even we can solve by at the very setup by using these m and n, eliminating using m, the value of m in given equation. You will get n, take n out, you can solve it. So then we use this integrating factor. It is 1 by mx minus ny, provided this is not 0. Let us have application. Let us see where we can apply this. I have not derived these rules. We can derive it very easily. We can derive, just as we have derived the necessary and sufficient condition for a function to be exact. And I have already told you there the necessary and sufficient condition for a function to be exact, differential equation, sorry, for a differential equation to be exact, that forms the part of syllabus of the undergraduate classes. But in case of engineering classes, you have to only read it, understand, apply in questions. You don't need it for that examination point of view. I would say the necessary and sufficient condition for engineering classes, but for UG classes it forms a part of the syllabus. You have to do the necessary and sufficient condition. That is the theorem that we did. Okay. Let me have your application. Application of this where we have the function of this form. I will take here application. I will take a question here. Let me take a question here. I will take this question. There are different questions. It is x square y square plus xy plus 1 into y dx, then plus x square y square minus xy plus 1 into x dy is equal to 0. This is my differential equation. I have to see first, is it exact? Is it exact? No, it is not exact. You see, this whole is your m. When you find out dou of m with respect to y, it will be, this will go in, this is 3 x square y square y cube, yes, this will be plus 2 xy, this will be 1. When I find out partial of n with respect to x, do you follow me? I am taking this x in, this becomes x cube. Derivative with respect to this is 3 x square y square. Take this x, this is x, it is minus 2x y, differentiation with respect to x. Take this x, differentiation with respect to x is 1. You see these two are different. 3x square y square, 3x square y square plus 2xy, but minus 2xy plus 1. So we say dou of m by dou y is not equal to dou of n with respect to x. Not exact. It is not exact. But at the same time, y common with dx, y common, and this is function of x. First term involves xy, second term only xy raised power 1. This is xy raised power square. You would write constant. You will say 1 is not a function. Yes, it is a function of xy. Every constant is a function of x. 1 x raised power 0, function of x. This one xy raised power 0. Note it, 1 xy raised power 0, function of xy. This one xy raised power naught, function of xy, function of xy, function of xy, function of xy. So y common, function of xy, x common, function of, it is the first rule. It has a integrating factor. Rule number second, we go to rule number second. What is its integrating factor? Well, it is integrating factor is 1 by mx minus ny. Let me find out here what is mx minus ny. Give the value of m. Be cautious. This is value of m. This is x y cube plus x y square plus y into x minus, give the value of n. This is x square y cube, this is x square y cube minus x square y plus x into y, x square y cube minus x square y plus x into this y. Okay, this comes out to be x square y cube plus x square y square plus xy minus x square, this we did here wrong. When we multiply this, it is x cube y square. This is x cube y square. It is x cube y square here. Multiply again, x cube y square, x cube y square, x cube y square minus x square y plus x. Rest is okay. Well, this xy, this is minus x cube y cube this is x cube y cube minus x square y square plus xy. Not plus xy, this is minus minus plus, this is minus. Okay, I will see again this. This is your x square y cube plus x y square plus y. Then this becomes x square y cube. This is x square y square minus xy. This was your x square x cube y square minus x square y plus x. Then we multiply by y. This becomes x cube y cube plus x square y square minus. This is here now x cube. This is x cube. X cube y cube plus x square y square plus xy. You see this and this goes, and you have this and this goes. It is x square y square. This is your mx minus ny. So what is integrating factor? So integrating factor for this is 1 by x square y square. Multiply equation first by 1 by x square y square. You see, when you multiply this x square y square, this comes out to be 1 by x square, this is 1 plus xy by this, it is 1 by xy. This is plus 1 by x square y square into y dx. Then plus, come here, it is 1 minus 1 by xy plus 1 by x square y square into x dy. This is now our transformed differential equation. This is a transformed differential equation. Let us see what happens. It is your y plus multiply by, it is your 1 by x, it is your 1 by x square y dx, it is plus x, it is minus 1 by y, it is plus 1 by xy square dy is equal to 0. This is equation second. by multiplying this by the integrating factor. Now we have to see, is it what? Exact. What is our m dash? Your m dash is y plus 1 by x plus 1 by x square y. When you find partial of m dash with respect to y, this will be 1, this is 0, this is minus 1 by x square y square. Why so? Because 1 by x square will be constant, derivative of 1 by y with respect to y is minus 1 by y square. It is this. Now here you have n is x minus 1 by y plus 1 by xy square. When you find n dash, what is dou of n dash with respect to x? We have to go derivative of x, it is 1, this is 0, then derivative of 1 by x is minus 1 by x square, it is minus 1 by x square y square. Yes, you see these two are equal, these two are equal, these two are equal. So this means equation number second is exact. So equation implies what? Equation second is exact. When it was not exact, we found it is integrating factor 1 by x square y square, we multiplied by this and this becomes exact. You see, now we solve it. What is the solution? It is solution will be integral of m dash dx plus integral of n dash dy is equal to 0. Here from n you have to take those terms which are free, which do not involve x. Here we have to treat as y constant, y constant. So write m dash full. What is your m dash? It is y plus 1 by x plus 1 by x square y dx plus integral of. Now this is your n dash. You have to take terms which are free from x. This involves x, omit it, delete it. This involves x, you also delete it, but you have minus 1 by y dy is equal to c. This is the solution. Okay. So this is how we convert the given differential equation which is not exact. This is y constant here, it is y integral of 1 with respect to x plus integral of 1 by x dx plus 1 by y integral of x raised to power minus 2 dx, it is minus integral of 1 by y dy is equal to c. This you can write xy, this is your plus log x, this is your minus 1 by xy. When you integrate x raised to power minus 2, this is your minus log y is equal to c. This is the solution of that differential equation which was not exact, but it was of the form, second form, rule number second. It satisfied rule number second. Then you have also rule number third. Rule number third. You see how we go for rule number third. I will state here rule number third. Method or rule number third for finding out integrating factor. We say if m dx plus n dy is equal to 0 is not exact. It is not exact, but at the same time you get a clue, you get a notion that partial of m with respect to y minus partial of n with respect to x. You find here partial of m with respect to y, you need it. Partial of n with respect, you need it. Division by n, when you write division by n is a function. If it is a function of x alone, when you simplify this thing, you simplify this factor, this del m by del y minus del n by del x by n is a function of x alone, then integrating factor is, say it is a function of x alone, say it is some function of x, say it is f of x, then integrating factor is, then your integrating factor will be e raised to power integral of f of x dx. So in this case, integrating factor will be e raised power integral of fx dx. In case it is not exact, but it takes this form, and when we find out this form, partial of m with respect to m minus partial of n with respect to x by n, we get only term involves x function. Even if you get constant, you can say, in case of constant, say you get this equal to 1, 2, in that case also you can say it is a function of x alone, then it is integrating factor will be e raised power. If it is constant 1, it will be e raised power x integrating factor. Let us have the application of this. On this I will take an application of this rule. Application, I will write here some application. Let me take a question here. I will write a typical question here so that you will understand it. It is, solve the differential equation, solve xy square minus e raised to power 1 by x cube dx is equal to x square y dy. Let us solve this differential equation. What is this actually? This is xy square minus e raised power 1 by x cube dx minus x square y dy is equal to 0. Our m is here xy square minus e raised power 1 by x cube, when our n is here minus x square y. What is partial of m with respect to y? It is your 2 xy. It is x, it is 0. Then partial of n with respect to x is what? Minus 2 xy. They are different. So you write partial of m with respect to y is not equal to partial of n with respect to x. If I subtract them, you see, I subtract these. When I subtract these, I will get, according to this, I will get this 4xy, and I divide by this n, I get only function of x. I get only function of x. You see how? You see. But what about partial of m with respect to y minus partial of n with respect to x by n? This gives you 2xy, that is already minus, it will become plus 2xy by, what is n? N is your minus x square y. Do you follow? So this gives 4xy by minus x square y. This gives minus 4 by x. It is what? Function of x alone. It is a function of x alone. So in this case, what will be your, yes, integrating factor. So integrating factor in this case is integrating factor. It is e raised power integral of minus 4 by x dx. That is e raised power minus 4 log x. That is e raised power log of x raised power minus 4. And it is log of e raised power log of x raised power minus 4 to the base e. You know, when you have e raised power log m to the base e, what is this? Simply m. You know this formula? It is simply m. You have e raised power log of x raised power minus 4 to the base e is this. So our integrating factor is simply x raised power minus 4. It is integrating factor. Therefore, we multiply the given equation by this, multiply given equation, multiply. So what is our, I'm sorry, this is not the, yes, it is our integrating factor, multiply, it is correct, I have found out here areas for this. Multiply first by x raised power minus 4 both sides. So you multiply this, it is x raised to power minus 4, this is x y square minus e raised power 1 by x cube dx plus, it is minus there, it is minus x raised power minus 4 into x square y dy is equal to 0. Well, this on simplification gives x raised power minus 3 y square minus x raised power minus 4 e raised power 1 by x cube dx, this is minus x raised power minus 2 y dy is equal to 0. What is your m dash here? Your m dash will be x raised power minus 3 y square minus x raised power minus 4 e raised power 1 by x cube. What is partial of m dash with respect to y? This is 2 x raised power minus 3 y. This is 0. Well, you have here n dash is minus x raised power minus 2y. What is partial of n dash with respect to y? Partial of n dash with respect to x we have to find out, sorry. With respect to x, it is this down plus 2 x raised power minus 3y. These two coincide. So yes, equation number second, it is this equation, transformer equation, is exact. It is exact. So what is it a solution now? You go with a solution. How you find out it a solution? It is exact. What is it a solution? It is integral of x raised power minus 3 y square minus x4 1 e raised power 1 by x cube dx. Here term is free from x, it involves x, so it is only c. You don't need n dash dy. Now integrate this with respect to x, it is y square. Look here, it is integral of x raised power minus 3 dx. It is minus integral of x raised power minus 4. I will take it in the numerator, it is e raised power, yes, x raised power minus 3, x raised power minus 3 dx is equal to 0. Here the suitable substitution for this very integral is now suitable substitution will be, it is y square x raised power minus 2 by minus 2. This is minus integral of x raised power minus 4 e raised power x raised power minus 3 dx. For this integral, if I put x raised power minus 3 is equal to t, this gives you minus 3 x raised power minus 4 dx is dt. This gives you x raised power minus 4 dx is minus 1 by 3 dt, because by differentiating this I get this. So it is a suitable substitution. So where we reach? This gives you minus 1 by y square by 2x square. This is minus integral of is equal to c is here it is your x raised power minus 4 dx, it is minus 1 by 3, it is e raised power t only, e raised power t minus 1 by 3 dt is equal to c. This you can write minus y square by 2x square. This is your plus 1 by 3. You know integral of e raised power t is e raised power t is equal to c. So this will be minus y square by 2x square plus 1 upon 3 into e raised power, your t is what, x raised power minus 3, that will be here 1 by x cube is equal to c. This is how we have explained 3 rules for finding out integrating factor. Number 1, when the differential this is not exact but it is homogeneous. Number 2, when it can be written in the form of taking y out with dx and xy terms, and with dx we have x out and dy terms, with dy we have x out and xy terms. And third one, when you have not exact differential equation but partial of m with respect to y minus partial of n with respect to x by n becomes a function of what, x alone, then integrated factor is e raised power integral of fx dx. Now we have the another rule, if it is not exact but in that rule it will become the function of y alone. In that case integrating factor will be e raised power integral of fy dy. I will discuss that later on, and I hope you will do the questions now on these 3 rules for finding out integrating factor. And till then we will wait for another video. It will be lecture 4th on this exact differential equations. Thank you very much. See you next. Okay.